Hey guys, today we are going to do differential equations in Laplace transform. That is, first of all, we are going to solve differential equations in which no initial conditions will be given. And then we will see its formulas and then we will solve its questions. Similarly, then we will solve differential equations in which initial conditions will be given. And then we are going to see its formulas and then here also we will solve a couple of questions. So first of all, we are going to look at the formulas for differential equation in which no initial conditions are given. Now guys, these are the formulas for differential equations in which no initial conditions are given. That is, suppose if we want to find the Laplace transform of yt, we will get the answer as ys, and if we want to find Laplace transform of dy by dt, we will get sys, and similarly if we want to find for d square y by dt square, we will get s square ys. So general formula for any value of dyn by dtn is this. That is, suppose if n is equal to 3, that is for d cube y by dt cube, we will write s cube ys, and so on. Now we will be doing a couple of questions using these formulae and it will become very clear to you that how you have to use these formulas. Now in question number 1, we have to find the impulse response, that is ht, by using this differential equation in which no initial conditions are given. So now we are going to use the corresponding formulas for it. That is, you will write d square y by dt square as s square ys. Similarly, you will write dy by dt as sys and yt as ys. Similarly, these formulas are applicable for dx by dt also. That is, you will write this as s xs plus 2 into xs. Now we will take ys common in the LHS and similarly we will take xs common in the RHS. That is, you will get s square plus 4s plus 3 into ys is equal to s plus 2 into xs. Now guys, we know that hs, that is the impulse response in the Laplace form, is equal to ys upon xs. So by looking at this equation, we will get the value of ys upon xs. That is, you will get s plus 2 upon s plus 1 into s plus 3. That is our value of hs. Now we are going to perform inverse Laplace transform on this to get the value of ht. That is what we have to find, the impulse response. So first of all, we are going to do its inverse Laplace transformation. Now guys, we will be using ILT formulas in this, which I have already explained in my video of inverse Laplace transform. So please first have a look at that video so that you are able to understand how we will convert hs to ht. Now guys, we previously obtained the value of hs, which came out to be this. Now we are going to convert it into partial form. That is, we will write hs is equal to a1 upon s plus 1 plus a2 upon s plus 3, which is equal to s plus 2 upon s plus 1 into s plus 3. That is, we have simply put the value of hs that we obtained before. Now we are going to use this in order to find the value of a1 and a2. That is, first of all, we will solve this part and we will cut the denominators from the LHS and the RHS. On doing that, you will get s plus 2 is equal to a1 into s plus 3 plus a2 into s plus 1. Now we are going to do necessary substitutions for s in this equation to get the value of a1 and a2. So first of all, we are going to put the value of s as minus 1. On doing that, you will get the value of a1 as 0.5. Similarly, we will put the value of s as minus 3. From there we will get the value of a2 as 0.5. Now guys, we have found out the value of a1 and a2 by doing necessary substitutions of s in this equation. Now we are going to put these values over here and get the value of xt using ILT formulas or inverse Laplace transform formulas. Now guys, on substituting the values of a1 and a2, you will get the equation as this. Now we are going to perform the ILT formulas. That is, we will use L inverse s minus a is equal to e to the power at. Now we will apply this formula over here. That is, on doing that, you will get 0.5 into e to the power minus t plus e to the power minus 3t into ut. That is, we have found out the value of ht. Now guys, if you are having a problem in converting hs to ht, please have a look at my inverse Laplace transform video, and I have provided that link in the description below. It will help you to understand these concepts better, as I have explained how to use these formulas in such equations. Now guys, this is our final answer, that is ht is equal to 0.5 into e to the power minus t plus e to the power minus 3t ut, and we found this by performing necessary Laplace transformations. Now we are going to do another question in which we will have to find the value of yt instead of ht. Now guys, in question number 2, we have to find the value of yt using LT method, and we are also given that value of xt is e to the power minus 4t ut. So while solving the question, we will first convert this into Laplace form. Now as we know that no initial conditions are given, so we will apply the corresponding formulas. That is, we will write d square yt by dt square as s square ys plus 5s into ys plus 6ys is equal to e to the power minus 4t ut. Now we will take ys common from here, that is, on doing that you will get s square plus 5s plus 6 into ys. Now we will convert this into Laplace form, that is, on doing that you will get 1 upon s plus 4. Now guys, we have to find the value of ys. So now on further rearranging this, you will get the value of ys as 1 upon s plus 4 into s square plus 5s plus 6. So on further solving this, you will get 1 upon s plus 4 into s plus 2 into s plus 4. So guys, this is our value of ys. Now we have to perform ILT on it, that is, we will have to convert ys into the form of yt as asked in the question. Now first of all, we are going to apply partial fraction over this. So now previously we obtained this, now we are going to convert it into the form of partial fraction. That is, we will write a1 upon s plus 3 plus a2 upon s plus 2 plus a3 upon s plus 4. Now guys, we are first going to solve this part of the equation, and we will cut the denominator from the LHS and the RHS. That is, on doing that you will get the equation as 1 is equal to a1 s plus 2 into s plus 4 plus a2 into s plus 3 into s plus 4 plus a3 into s plus 3 into s plus 2. Now we are going to substitute necessary values of s in order to find the value of a1, a2 and a3. That is, first of all, we are going to put s as minus 3. On doing that, you will get the value of a1, which will come out to be minus 1. Similarly, you are going to put value of s as minus 2, and on doing that you will get a2 is equal to 0.5. Then lastly, we will put value of s as minus 4, and we will get the value of a3 as 0.5. Now guys, we have found out the values of a1, a2 and a3. Now we are going to put these values in this equation and get the value of yt, that is, by using necessary ILT formulas. Now guys, we have substituted the values of a1, a2 and a3, and we got this equation. Now we are going to use inverse Laplace transform formulas and find the value of yt. That is, we will get the value of yt as minus e to the power minus 3t plus 0.5 e to the power minus 2t plus 0.5 e to the power minus 4t into ut. So guys, this is our final answer that we found out using ILT on this equation. Now guys, we are going to solve differential equations in which initial conditions will be given. So first of all, we are going to look at its formulas, then we will do a question on it, which will help us get a better hold on our concepts. Now guys, these are the formulas that we will use while solving differential equations in which initial conditions will be given. That is, now you will notice over here that as compared to the previous formula that we used for the differential equation in which no initial conditions were given, these are the extra parts over here. That is, previously we did not have these. So these are the initial conditions that will now be given in the question. And furthermore, these formulas are also applicable for x, that is for dx by dt, dx square by dt square, dx cube by dt cube also. So now we will be doing a question on it, which will help you understand that how you have to apply these formulas. Now guys, in this question we have to find the value of yt, and you can see that we are also given the initial conditions, that is y0 is equal to -2 and y dot 0 is equal to 0. And furthermore, you should also know that y dot 0 can also be written as dy by dt 0. And similarly, we can write y double dot 0 equal to d square by dt square. So now we are going to solve this equation using the corresponding formulas, as we know that the initial conditions are given. So first of all, we will write this in the form of a Laplace transform equation, that is s square ys plus s y0 minus y dot 0, that is we have also applied the initial conditions here, plus 7ys minus 7y0 plus 12ys is equal to xs. And as we are given the value of xt as ut, so value of xs will be equal to 1 by s. Now guys, we are going to put the values that are given in the question, that is we will put the initial conditions over here. On doing that, you will get s square plus 7s plus 12, that is we have taken out ys common along with putting the values of initial condition in this equation, and 2s plus 14 is equal to 1 by s, that is we have used this over here. Now we are going to find the value of ys. So on rearranging this, you will get ys is equal to minus 2s square minus 14s plus 1 upon s into s square plus 7s plus 12. Now guys, we will further solve this, that is we will further solve this part of the denominator, and we will get minus 2s square minus 14s plus 1 upon s into s plus 3 into s plus 4. Now guys, we are going to apply partial fraction over this, and then we will use ILT formulas and get the value of yt. Now guys, previously you obtained this value of ys. Now we are going to write this in the form of a partial fraction, that is we will write a1 upon s plus a2 upon s plus 3 plus a3 upon s plus 4. Now we are going to solve this part, and we will cut the denominators from the LHS and the RHS. On doing that, you will get the equation as minus 2s square minus 14s plus 1 is equal to a1 into s plus 3 into s plus 4 plus a2 into s plus 4 plus a3 into s plus 3. Now guys, in this equation we are going to put necessary values of s in order to find the values of a1, a2 and a3. That is, first of all, we are going to put the value of s as 0. On doing that, you will get the value of a1, which will come out to be 1 by 12. Similarly, we are going to put the value of s as minus 3. On doing that, you will get the value of a2, which will come out to be equal to minus 25 by 3. And lastly, we are going to put value of s as minus 4. On doing that, you will get the value of a3 as 25 by 4. Now guys, we have found out the values of a1, a2 and a3. Now we are going to put these values in this equation and get the value of yt by using necessary ILT formulas. Now guys, we have put the corresponding values of a1, a2 and a3 in the equation of ys that we obtained previously. So now we are going to use necessary LTI formulas in order to convert this into the form of yt. So first of all, we are going to use the formula L inverse of 1 by s is equal to 1. Now guys, you must remember that we used this formula before also in this question itself. That is, we were given that xt is equal to ut, and we had converted xs is equal to 1 by s. We had been able to do so because xt is equal to ut can also be written as xt is equal to 1. So Laplace transform of 1 is equal to 1 by s. That is xs is equal to 1 by s. So this was the reason behind putting the value of xs as 1 by s. That is L1 is equal to 1 by s. We have got it from here. That is we have transferred L on the RHS. Now similarly we are going to use 1 upon s minus a, L inverse of 1 upon s minus a, which is equal to e to the power at. We will use this formula over here and get the value of yt. Now on applying these formulas we will get 1 by 12 minus 25 by 3 into e to the power minus 3t plus 25 by 4 into e to the power minus 4t into ut. Now guys, this is our final answer that we found out using LT method. I hope that you were able to understand all of these questions, and now you will be able to do all the questions related to differential equations in Laplace transform. Now guys, after watching this video, please do not forget to subscribe, like and comment.